So the first two civilizations we'll come to in our survey of science and society in the history of the world are Mesopotamia and Egypt. We talked last time about the Neolithic Revolution and how people began to settle down in territories along major river civilizations. And so today, in this video, we're going to take a little bit of a look at Mesopotamia, this region here in Western Asia, and Egypt, this region here in North Africa. Often termed the Fertile Crescent, this region of Mesopotamia combines ancient Kuwait with Iraq, parts of Iran, and as you can see, moving down into the Holy Land. Often called the Fertile Crescent because if you're trying to travel from Asia to Africa, if you're trying to travel from Asia to Europe, this is the region you want to get to because there's water, there's agriculture, there's resources. It is a river valley, so it's easier to traverse than the mountains. And ancient historians, ancient anthropologists believe that there was a lot of cultural exchange going on here because people did indeed travel from, say, Europe to India by going through this region, from Africa to Europe, from Africa to Persia by going through this region. And so we are convinced that there's a lot of exchange of ideas, of information. All of these societies working together. We'll find as we move forward that, particularly with the sharing of technology, this is very important because technology is something that once it's achieved, typically is not lost, right? So once you learn a certain technology, you typically don't unlearn it. You typically don't lose that knowledge. So starting with Mesopotamia, let's just go with the basics. Mesopotamia is around as a civilization certainly between 3600 and 1600 BC. Probably that time period could be lengthened on either end. It's located in the Tigris and Euphrates River Valley. Again, as we said earlier, this is ancient Iraq and ancient Kuwait. There are a lot of firsts in Mesopotamia. They have the first written language. If you've taken a look at that presentation on the history of the alphabet, you know that cuneiform is one of the earliest languages, if not the earliest language in the history of humankind. They crafted one of the first mathematical systems. Perhaps not the absolute first, we're not for sure, but we know that the Mesopotamians had a systematic approach to mathematics and they used a base 6 approach, often called the sexagesimal approach, so base 6. Americans prefer the base 10 system. This is one developed by the Greeks. The Greeks are much more interested in categorizing things by tens. For Mesopotamia, base 6, and we'll see a little bit more about why on that in a moment. Because they have the first written language, and perhaps because they are using mathematics to think not only in perhaps systematic ways, but maybe, and we'll get to this in some abstract fashion, we get the first epic literature also out of Mesopotamia. The first great stories of the heroic, the connections between life and death, between the heavens and the world. And one of the major themes in this first epic literature, this is the Epic of Gilgamesh, is how do we connect city living in community with the natural world around us. Again, that's one of the great questions associated with science. How do we associate ourselves with the world around us, the world of nature, when we become urban livers, urban dwellers? And are we part of nature? Is nature something to be controlled? The Mesopotamians also have one of the first written law codes. We'll take a look at this very briefly because one of the things that this law code deals with in Mesopotamia is regulating the activities of doctors, of surgeons in particular. We said before with the Fertile Crescent that Mesopotamia is indeed influential. Situated in the Fertile Crescent, they are able to influence a lot of different cultures that come through the region or are connected to the region. So we'll see that in Mesopotamia, we are engaged in peoples in Egypt, peoples in India. The Hebrews hang out in Mesopotamia. You probably know this if you know your Hebrew history. They are there as well. Abraham maybe came from one of the city-states of Mesopotamia, the city-state of Uruk or Ur. And many others are going to be influenced by these peoples living here. So what kind of specific contributions to the history of science and to the history of technology do they make? Your book, McClellan and Dorn, will talk a lot about the role of irrigation in an ancient society, in any society really, and what it takes to achieve irrigation. And they wrap this up in their hydraulic hypotheses. Please take a look at this. But it is this idea that when you organize society around such an important engineering process that irrigation would be, you absolutely make some decisions, right, on the role of people in society, the role of men versus women, the role of leaders versus the common worker, the role of people who know how to use math and writing in order to design irrigation systems, right, might somehow have a different social value to society, might certainly have a different role or function in society. We're going to go from hunters and gatherers to settled farmers, right? And so that is going to be a difference in the way that human beings live in society. So this idea of irrigation and this hydraulic hypothesis that McClellan and Dorn come up with, certainly evident in the world of Mesopotamia. Writing. We talked already about this idea of in other videos about the importance of writing as a technology. You want to record observations in the basic scientific method, and you cannot do so without writing. You want to record it and then have other people be able to take a look at it, right? To verify or challenge your findings. And again, you can't do this without some kind of notation system. So again, from Mesopotamia, we get the first writing in cuneiform. And as we said earlier, we get this law code called Hammurabi's Code, which helps us to understand how that society is organized, how that society prepares for war, how that society approaches justice. And one of the specific examples that Hammurabi's Code offers is this idea that doctors are held accountable for the patients whom they blind. So we have specifically in Hammurabi's Code an example of surgeons conducting cataract surgery. Yes, in Mesopotamia, in as early as 1700 BC, if not before, we have doctors, so-called medical professionals, so-called, who are attempting to remove cataracts from people's eyes using surgery. So extraordinary evidence to let us know sort of the state of medicine in Mesopotamia, but also that if you are a doctor and you blind a person, maybe you didn't even mean to, but you blind a person in surgery, you're going to lose your hand as a punishment. The other thing we get in Mesopotamia that's important for the history of science is a mathematical system, as we said earlier. And this is that sexagesimal system we'll talk a little bit more about. And it's also important for both writing and math. You need both writing and math to develop some of the first examples of, can we call it scientific thinking in Mesopotamia? We are charting the stars. We are keeping track of celestial bodies and their movements in the heavens. And we're also using that information to develop calendars that are important for us for our agricultural cycles, calendars that are important for us for our religious festivals and cycles, right? So some very interesting developments in irrigation. We might call that engineering or a technology. Writing, also a technology. And math. I'll leave it to you to decide if math is a technological development or a scientific development. Just a few examples of what we've been talking about. Pardon me. This is a English version of a cuneiform tablet that is essentially a map of an irrigation system, right? So here we have, if you can see, this canal. This is human-made. This is an irrigation canal. And we're understanding, excuse me, that canal then goes off into other areas. And in between, we have fields. These are fields to be worked. These are agricultural fields. And so, pardon me, we have this very interesting map. We have this gentleman over here who's tried to recreate what he thinks this map would look like in model form, which is very nice. So what you can see from this is that in this field, the produce from this field somehow benefits the gate of the city. We don't know if that's the gatekeeper, the person who runs defense for the city. We don't know exactly what that's for. Then you have a field of a particular priest, right? A field where the produce somehow goes to the palace. So we know that we have fields dedicated to religious leaders, fields delegated to political leaders, and then perhaps this stream that gives drink, the stream that gives water. So is that public water? We also have a fellow by the name of Quatnu or Katnu. We have a fellow by the name or a woman by the name of Ludu'u. So there are also, again, references to other peoples besides leaders. So when we start to see that irrigation hypothesis, right, that hydraulic hypothesis, we see from this map that indeed irrigation, when we map it out using math, using writing, using pictographic representation, that we also see social and political results with this advent of irrigation. You've been looking at a video on the history of the alphabet, and in your McClellan and Doran, they'll talk a lot about the role of writing as a technology. Cuneiform, the first writing from Mesopotamia, simply means wedged shape. We think that the writing was done by taking a reed stylus, like taking a reed from the river, sharpening it like a nice pen, and using that to make impressions in clay tablets. So therefore, you get this sort of wedge-shaped indentation in the tablets. It is picture writing. It is picture writing, and as your video said on the alphabet, we do think there's some development over time, and this little presentation on your left is meant to sort of show that. The video talks to you about how perhaps, say this is an ox, right? And you can see that it's a picture of an ox, nice little wedge-shaped head, and then you get the horns here. Over time, for some reason, it falls to the side. Maybe that's easier for the scribe to make that way. And over time, again, you see it start to change. And that seems kind of an odd representation pictographically of an ox, but your video suggests that it's just faster to write it this way. So we've gone from sort of pictures to faster notation, just jotting boom, 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 right? Several indentations to get us there. So for example, the sun. Here is what looks to be like sort of the setting sun, right? So here's the horizon perhaps and the sun going down. And again, then it turns. Perhaps it's easier to go that way. And then you've got sort of four sides here representing that same figure, but they're squared off instead of curved. So that takes less time. And then for whatever reason, and again, I can't tell you myself, we move to this as a faster notation of the sun. So again, starting off as picture writing, mud tablets, if you will, clay tablets, and moving into more complexity as time goes on. This is just a larger example to show you how really complex this could be, how very busy these scribes could get keeping records. We think, if I'll back up a second, we think on cuneiform that primarily we're keeping records of materials we have on hand. We're keeping records of maybe king's lists, who's the king this year and how long has that king ruled, and also perhaps religious festivals. Also literature, though. We have our first example of epic literature comes from the Epic of Gilgamesh. And some of you may have read this. We said before that the Epic of Gilgamesh does have an incident, one short story within it of how these two fellows meet. This is Gilgamesh here and his best friend Enkidu. And what happened was the townspeople of Uruk decided that Gilgamesh was just a handful. And so he needed a sidekick, someone to keep him from getting bored, someone to go on adventures with. And so they had to go out in the wild and get a wild man. And the story of Enkidu is the story of moving from the world of nature to the world of the city and becoming sort of part of city living. And so that's very interesting from the perspective of science and society, that the people of Mesopotamia believe that they're somehow connected to nature, but somehow separate as well, right? So that they're observers of nature. What else can we say? This epic literature also tells us what we think our kings ought to be like. They should be strong. They should be powerful. They should be able to defeat lions, as this image shows. So a very interesting literature to start with. The Code of Hammurabi, we said before, the first law code. This fellow Hammurabi is an actual king. We think he lived. Maybe Gilgamesh didn't live. We don't know for sure. But this fellow actually lived. And here is the god Shamash, the god of light, the god of truth, who is handing over to him a scroll, as you can see here. This image shows you a little bit more of the cuneiform written below. This is the actual code here, some 252 laws inscribed. And again, this is where we find that law on doctors and their behavior. The sexagesimal system, a base 6 or base 60, it says on this slide. I'll be honest, it is an art to be able to read, Babylonian numerals. But just to give you a bit of an understanding, this straight wedge-shaped stroke, like a single stroke, and if you watched your video on the number 1, which is coming up in the next week's materials, take a look at that. You'll see more of this. And then this wedge seems to be 10, right? So 5, written much like you would think, 1, 2, 3, 4, 5. Yeah? And then 12, here's a 10, 1, 2, right? Makes good sense, yep. Notice how the ones he says in these two are shown on the right, and this is very similar to a Hindu-Arabic system, so an Arabic system as well. So 10 plus 2 is 12. That's pretty much how we would write it. 45, 1, 2, 3, 4, right? So that's 40, and then 5 to go. So we have that's a explanation for things like you would see here. And so, for example, here we see again the number 32. So 3 wedges going this way, 10, 20, 30, and then 2 going this way for 32. This number here becomes 16, 10 plus 6, and so forth and so on. We think that the Babylonians could, out of Mesopotamia, could use this numerical notation for lots of practical purposes. This one in particular is meant to show, this is a table for lengths. This is probably a table used to express, as the notation says, area. And so we think that, we're thinking back to that map of the irrigation map, this would help you to know a little bit about how much area is in each of those fields, right? We find in early civilizations that were very much concerned about measuring agricultural fields vis-a-vis the water system that supports them. And you can understand why, right? How much water do you need at this field? If a flood comes up, how much of the field is now arable? If a flood doesn't happen, how much of a field can now be worked if there's a lack of water? Mesopotamian math is very interesting in the history of science because the Mesopotamians, like all ancient civilizations, believed that the earth was round. It is a misnomer and it's a modern misnomer, it's a modern myth that ancient peoples ever thought the earth was flat. They always believed it was round. Everything they saw in the heavens was round, and so they believed that the earth itself was also round. If you live close to the shore in antiquity and you watched a ship sail away, the ship sailed away on the horizon and then sort of sank as it got far out of view. And it's because the earth is curved. The ship didn't sail away and then fall over as it got to the edge, right? So they always knew that there's a curvature to the earth. The Mesopotamians in their base 6, using astronomical observations and using their own mathematical calculations, developed the concept that there are 360 degrees in a circle. We know that this is the case because this is what we say today. So a round object has 360 degrees. A calendar for them, therefore, using both the movements of the suns and understanding that the earth is round, is 366 days. Now that's off a bit, as you well know. But that is one of the creations of the Mesopotamians. Keep in mind that, as you know, that there are 24 hours in a day. There are 60 minutes in an hour. There are 60 seconds in a minute. So the Babylonians had it going on with regard to this idea of base 6, and that made perfectly good sense to them. The other thing to put here for your attention is this small little tablet where, now again, I can't do the cuneiform as someone has done here, but what they've done is they've shown how this particular little tablet that has been found using cuneiform is a schoolboy's attempt to try to derive the square root of 2 by calculating it out to about 6 decimal points, right? So what times what equals 2, and they're calculating the square root out to 6 decimal points. So this is a very impressive approach at abstract math. Yeah? So why important? The concept of a square root is a prerequisite to and ties in with many other concepts in mathematics, functions, graphing, geometry, trigonometry, irrational numbers, going towards real numbers. So this idea of trying to play maybe a math game, we think, with the square root of 2 is to start the Mesopotamians, and therefore us as their cultural heirs, on the process of scientific mathematical thinking. One of the other elements that you'll find in all ancient civilizations is an attempt at what we might call monumental building. And monumental building requires mathematics. It requires a little bit of trial and error. It requires engineering, right? And of course, lots and lots of human energy, human labor. And what we have here are a couple of examples of ziggurats. A ziggurat is the monumental building in Mesopotamia. And it is phenomenal, these ziggurats. This one is attempting to be restored in modern day Iraq. What you see here, this is all restoration. This is erosion. This is a mud brick building, some 7 stories high. This is erosion most likely from wind, but also, of course, from water, from rain. And this is an attempt today that's been going on probably since the time of Saddam Hussein to restore. This is all here. These are just, buildings, temporary buildings for the workers to help restore it. This is what an architect believes and is sort of what it might look like. The ziggurat at the city-state of Ur might have looked like. Again, a grand ramp where people would go up, right? If you are a priest, you might be able to go all the way to the top, and we think this is where the priests who developed calendars for Mesopotamia did their astronomical observations and recorded the data that they found. We think these Mesopotamian ziggurats could also be granaries where we're storing up supplies, maybe because we need to redistribute them in times of crisis. We also think that these ziggurats are where we stored up military equipment. So we found cuneiform lists that talk about what are here. So a very interesting, impressive kind of building, wider at the bottom, right, than at the top. So a pyramid sort of shape, if you will. And this is a very common approach to building. If you want to build large and tall in the ancient world, is a nice wide base and getting smaller as you go up. This is, again, a modern day representation of this. And as you can see, the top has been sort of eroded, and we're trying to restore from the ground up. This is a ziggurat that has not been restored, nor has it had an attempt to be restored. And you can see the erosion pattern, again, very interesting that the erosion pattern has kind of made this almost curved looking now because of the winds. I like this one too because you can see people and get some kind of perspective of how large this thing would be. Here's another example, and it's almost become modern art with erosion. Again, we're trying to restore some of the ziggurat, trying to hang on to it, but time, 5,000 years of wind is going to do a number on such things. This is, I like this one. This is Sacramento's, the capital of California. This is their government building, and it's a ziggurat. It's a ziggurat. Fascinating, yeah, fascinating. We still like this form of architecture. So some conclusions about Mesopotamia in this first little video on the ancient world and science. Mesopotamia was a first in many ways. Their civilization depended on and developed because of organized irrigation. A multitude of technologies associated with, with textiles, pottery, metalworking, and again, McClellan and Dorn are going to go through all of those. They had writing, they had math, medicine, astronomy, monumental building. All these things attest to the technology associated with sophisticated record keeping and a society's attempts to harness the power of nature and manipulate nature to suit its needs. Right? So Mesopotamia, one of the first civilizations in our Neolithic revolution, the development of a science and technology to try to harness the power of nature around us and to try to figure out a way to use and to observe and to use those elements around us to our benefit.